that you give us the courage to ask where we've not understood. And I pray that you continue to bless our teachers, Lord, and give us a good day today. In the mighty name of Jesus Christ, I believe I've prayed. Amen.
Amen. Can you see our chalkboard well?
Yes.
Okay. From last week, our teacher introduced chemical formulae. So today we are going to start on balancing equations, and then we continue with the whole process. We are going to try using the board. If we fail, then we can use something else. But for now, we are going to be using the board. So let's start. If we listen to this word called balancing equations, so I say I have an equation, I need to balance it. What do you understand? What do you pick when I say I need my equation to be balanced? Let's start from there. Daphne?
Teacher, I think when I hear the word balance, it's like you're trying to make the whole equation equal.
Okay, that is fine. The whole equation equal. Okay, Amelia, what do you understand by balancing equations?
I think balancing an equation is trying to make all the elements the same, all the symbols of the same element have an equal amount, like the equation and the answer have equivalent.
Thank you very much. I'm going to give one example. Then after, we go through the steps together after seeing what we are meaning. Thank you very much. All your answers are correct. But I have this equation that our teacher used last week. Can you see our chalkboard very well?
Yes, teacher.
Okay, hydrogen is a gas, oxygen is a gas, then later we form water, which is a liquid. Now, when you talk about balancing an equation, we are trying to make sure that the atoms on the left-hand side, and those ones, we call them reactants, are equal to the atoms in products, and our products are on the right-hand side. These are the products. So our main job now is to make sure that atoms on the left-hand side are equal to the atoms on the right-hand side. That is what we call balancing. So I'm going to do one example. Then we use this example to go through the stages or the steps to follow. Number one, I need us to identify the atoms on the left-hand side. I'm going to say we have hydrogen, we have oxygen. That is on the left-hand side. On the right-hand side, I have also hydrogen and oxygen because we have hydrogen gas, we have oxygen gas. In water, we have hydrogen atoms and we have oxygen atoms. So the first question is, how many atoms of hydrogen do we have on the left-hand side? By show of hands.
Nothing.
2 atoms.
So I come and put a 2 here. So how many oxygen atoms do I have on the left-hand side?
Amelia?
2 atoms.
Good.
Of
So
oxygen.
let's go on the right-hand side. So our first step, I'm going to say our first step, we have to first understand the atoms that we have on the left-hand side. and the atoms that we have on the right hand side. How many atoms do we have for hydrogen on the right hand side?
Joanna,
2.
How many atoms do I have on the right hand side for oxygen?
Mercy,
One
Good.
oxygen atom.
So our first step is to identify whether atoms on the left hand side are equal to the atoms on the right hand side. When I look at hydrogen, on the left hand side I have 2 hydrogen atoms and I have 2 hydrogen atoms on the right hand side. So I would say that hydrogen atoms are balanced or they are fine. When I go to oxygen atoms. For oxygen on the left hand side I have 2 atoms. On the right hand side I have 1 atom. That means that oxygen atoms are not equal on the left hand side and right hand side. So they are not balanced. So they make the whole equation not balanced because some atoms on the left hand side are not equal to the atoms on the right hand side. That is step 1. We've identified atoms on the left hand side and atoms on the right hand side and seen that oxygen atoms are the ones that are not balanced. So what are we going to do? Since we see that we have 1 and we have 2, we are going to multiply through numbers. Now I like using left hand side. So it's the term that I'm going to be using now. If I look at this equation of mine, I'm going to call this part the left hand side of this formula. I'm looking at the formula of water. So we have oxygen as 1, but here oxygen is 2. So what we do is to multiply through a number that will give us 2 on the right hand side. So what number can I multiply through by 1 to give us 2?
Amelia,
2.
So I multiply through by 2, which will give me 2. But this 2, now we have a situation here. You have to multiply through a formula. When you look at this hydrogen, I cannot come and put a 2 here because it will change the formula. This is no longer water. This is now hydrogen peroxide. So when you put it on the right hand side, it is criminal. When you put it on the right hand side of the atom, that is criminal. You can never do that. So you leave the molecule intact as it is. So we always add those numbers. With time, we're going to call them coefficients. We add those numbers on the left hand side of the formula. My formula of water is 2. So it's this. So I'll put my 2 here. Then, if you remember the first lesson that we had, we said when we put a 2 here, it affects, or any number here, it affects everything in this molecule. That means that 2 affected oxygen. Initially, oxygen was 1, now oxygen will be 2. The only challenge that we'll have is that these 2 outside brackets, or these 2 on the left hand side of the formula, will affect all atoms inside the formula. So now when we look at this formula, how many atoms of hydrogen do we have now since we put a 2 outside? Because it is impossible for us to put 2 on oxygen only. We must put it on the left hand side of the whole molecule. So what do we have as hydrogen? How many atoms of hydrogen do we have now?
Lindsay,
4.
4. So even 2, this hydrogen, which was initially 2, has been affected by this number to give us 4. That means that we tried to work on oxygen, which is now fine, but in the process, we disorganized hydrogen. That means we also have to make sure that hydrogen is sorted again. So, since hydrogen on the right hand side is 4, what can we do to make sure that even on the left hand side it is 4? By show of hands. We have 4 on the right hand side, but on the left hand side we only have 2. What can we do to make sure that we also have 2 on the left hand side?
Benjuka,
We add another 2 in front of hydrogen.
Okay, thank you. Do we add or only multiply when we are balanced?
Multiply.
Good, thank you. So multiply by 2, this will give us 4. But remember, this multiple that we are multiplying to or that we are adding, the number that we are multiplying to, we only put it on the left-hand side of the formula. Remember that. So I come where is hydrogen? It is here. Left-hand side of the formula. Some books they say in front of hydrogen, but I said I'm going to be using left-hand side. So I put a 2 here. When I put a 2 here, in this formula we only have hydrogen. So that means it will only affect this hydrogen. 2 times this 2 will give us 4. So since hydrogen atoms are the same on the left-hand side and the right-hand side, the number of hydrogen atoms, even now the number of oxygen atoms are equal both on the left-hand side and the right-hand side, we conclude that our equation is now balanced. Okay, I'm going to use this example to go through the steps. Then after going through the steps, you ask questions. After asking questions, we can start on our example.
Excuse me, sir. I don't understand what you're doing.
You're lost.
Yes, sir.
Okay, that's why I'm saying now. Let's go through the steps, then we'll start again and we follow. For those who are still so lost. Okay, okay, now chemical balancing, chemical equations. That's what we're doing. We've said we are trying to make sure that the atoms on the left-hand side are equal to the atoms on the right-hand side. So I need us to read through these stages together, all these rules. Then after, we can define the whole process of balancing equations. Then we will relate it to what we've done on the chalkboard. Then we see if we are together. So, rule number 1, or step number 1. Can someone read for us number 1?
Write the formula of the reactant
Angel?
on the left-hand side and the formula of the product on the right-hand side.
Thank you very much. Step 1, we are writing the formulae. It can be one or they can be many. Of reactants, left-hand side, formulae of products on the right-hand side. That is step 1. Step number 2.
Balance the equations if necessary by writing numbers in front of the formula.
Okay, step number 2. We are writing numbers in front of the formulae. That's why I said I'm going to be using the word left-hand side, but we only write numbers in front of the formulae. I think now when I talk about in front of a formulae, you understand because you've seen us write numbers in front of formulae or on the left-hand side of formulae. Now, this whole process of writing the equation, then adding in numbers in front of formulae to make sure that atoms on the left-hand side are equal to the atoms on the right-hand side. That whole process is what we call balancing equations. So, question 1, before I can illustrate. Question number 1, before I can illustrate this, and then you ask questions. What do you understand by balancing equations?
Making them equal.
Definite hand is up. Maybe you can hear from her.
Teacher, I had a question. Like this balancing, does it come like, let me say, if they tell you to add, let me say, potassium, to write the chemical formula for potassium permanganate, and then does it come like when you have to, after writing it, you have to balance, or they give a specific question and tell you to balance?
Okay, thank you very much. Is that Daphne?
Yes, teacher.
Okay, thank you very much for your question. We always write chemical equations. Chemical equations are written when there is a reaction taking place. If you can remember reactions of magnesium with oxygen, or reactions of metals with oxygen, or reactions of metals with water, all reactions that we always talk about. We have substances reacting together and they are forming these things.
Okankunda, please mute your mic. Okankunda, please mute.
Sorry.
Okay, I've muted everyone. So in case you want to say something, remember to unmute yourself first. So I was telling Daphne that we always do this when we are having chemical reactions. We have two or more substances reacting together and they are giving us products. That's when we try to make sure that the number of atoms on the left-hand side for reactants is equal to the number of atoms on the right-hand side for products. But when we are just writing a chemical formula of one substance, it may not apply the other part of exchanging valencies, because there you're writing one thing like this. So we only balance equations when we are having reactants and products at the same time. Thank you very much, Daphne. Hope that answers your question. But I had also posed a question. What do you understand by balancing the equations right now after this illustration?
Mr. Ajana, we have Nchongo. Angel Nchongo, you can unmute.
Teacher, from your explanation, I think balancing equations is like making sure that each atom of an element on both sides for the reactant and the products is equal. Like if hydrogen has two atoms on the reactant side, and it should have two atoms on the product side as well.
Thank you very much, Angel. Do you have someone who needs to add something? Because that's a very perfect answer.
Mutoni's hand is still up.
Teacher, I have a question.
Yes, go ahead.
In the last chemistry lesson we had, the teacher said something about the atomic molecules like hydrogen and oxygen.
Yes.
And she said that you write the two at the bottom, but the products you don't add, you use only the valencies. So I'm confused about that. Are we supposed to always balance the equation or only when we are asked? Could you talk about that?
Thank you very much, Esther. So, Esther, I'm going to answer your question, but before that, I need us to first go through this definition together. Then I answer Esther's question. I pick more questions, then we continue with the examples. Can someone read for us this definition, the first paragraph that we have? Then I can answer Esther's question.
Rebecca.
Balancing chemical equations. A chemical equation is not correct unless it's balanced. The process of making the numbers of atoms equal on both sides of an equation is called balancing an equation. This is done by writing small whole numbers in front of symbols and formulae.
Read the next paragraph.
To confirm that the equation is balanced, the number of atoms of each element on either sides of the equation must be equal.
Thank you very much. That's what I need us to first understand, all of us. So I'm going back to Esther's question. And in case you also have a question you can ask, then I'm going to start on examples. Okay? So I'm going to share the chalkboard alone. So Esther, last week this Monday, when our teacher was teaching, I was also there. And she told us that when these reactants are going to react, initially, before they have reacted, they exist as diatomic molecules. That is perfect, you got it well. In this case, oxygen here has not reacted. In the atmosphere, it's existing like this, diatomic. You see, there is that two, my diatomic. So oxygen in real life, it exists as a diatomic molecule. We put it there. Hydrogen gas. She also told us that hydrogen gas in real life it's diatomic. Before it has reacted, it's still diatomic. That's why I wrote H2s are always written as subscript on the right hand side. 2 here, 2 here. But you also need to remember something so that when we are balancing, we only write in front of a formula. In front, I say that I like using this one on the left hand side of the formula. So this is the number that I add for balancing. So for balancing equations, we only add numbers on the left hand side of the formula or on in front of that formula. So to answer your question, I'm still moving. Students, let's try to move together. When these gases or when these molecules are going to react together, hydrogen, it comes as a reactant, oxygen also comes. They first break down to start reacting. Then when they start reacting, they react using their valences, and each atom reacts. Pick that. In real life, they are 2, they are diatomic. But when they come to the lab and they want to start reacting, they break and each atom reacts differently. I need to give an example when you're in a home. You live as a family, 2 students, 2 people, 5 people. But when you come to schools and you're meant to do exams, each student will do his or her own paper and they take back report cards at home. So even this hydrogen, when it's time to react, they see what I remember our teacher teaching. Hydrogen atoms will break, each hydrogen atom will come with its valence. We are forming a formula of hydrogen, of water, what has been formed. This oxygen, the atomic molecules will come, they also break, each atom reacts differently or separately. So each high oxygen will come with its valence, it comes here, this will give me H2O. This is how we get water. Because these the atomic molecules, when it's time to react, they break, then each atom reacts differently. Or they react separately. Of course, all of them form water, but not like, you see how these numbers are coming? Whoever asks Esther, is that correct?
Teacher, I'm still confused.
A little. So we are going to do 3 numbers today, 3 or 4. When we are on the 4th example, when you're still confused, you tell me. But make sure that I know you're very keen to see how we write these numbers. That by the end of
Excuse me,
that
I'm
lesson,
confused.
put down your name. I'll ask if you're still confused, okay?
Excuse me, so I'm still confused.
Okay.
Actually,
I haven't understood. Can you explain?
We are going to do an example.
Okay. So we are going to repeat this example since we now know what balancing means.
teacher, I have a different question.
Yes, go ahead.
And teacher, does it mean hydrogen when you're writing the H2, you just write it as H2, but in the real sense, it's carrying 1?
Okay, thank you very much. So we said hydrogen comes diatomic in life, real life. Oxygen comes diatomic as our teacher told us in real life. But when they are going to react, remember how they form water. But if we say each atom keeps reacting, oxygen we have on the left hand side?
2.
Okay. Let me go on the right hand side. How many atoms of hydrogen do we have on the right hand side?
2.
Next, how many atoms of oxygen do we have on the right hand side?
1.
Good. Thank you. So our main job is to make sure that atoms on the left hand side, the number of atoms on the left hand side is always equal to the number of atoms on the right hand side. So we start. If I look at hydrogen, the numbers are the same, so that is fine. I'm going to oxygen. Left hand side, there are 2. Right hand side, it is 1. So that means oxygen is not balanced. Or the number of oxygen atoms are not equal on the left hand side and the right hand side. But we say that when we are balancing, we write numbers in front of the formula or on the left hand side. So what are we going to do for this oxygen to make sure that oxygen atoms are equal on both sides? By show of hands. I see many hands. Maybe.
We put 2O in we put 2. So that oxygen 1 atom, we multiply the 2 outside brackets, atom to get 2. And then we put 2 on the side on hydrogen, on the reactants. On the left hand side of hydrogen, so that make it equal product where there is a on the in the out that we get 4 on the product.
Okay, thank you very much, Amelia. I have someone who understood. That is Amelia. Thank you very much. If we're in class, we'll clap for you. Now, I'm going to go through what Amelia has taught us. She has taught us that on the right hand side, since I see oxygen is 1, I multiply it by 2, which will give us 2. But they said when we are balancing equations, we are only allowed to write these numbers in front of a chemical formula. So we come where oxygen is, it is in water. We cannot write beside any number. So we have to write in front of water, on the left hand side of water. So I will come and put my 2 here. But from our first lesson, we said when we have a number on the left hand side of a chemical formula, that number affects everything in the formula. So that means these 2 will affect number of hydrogen atoms. These 2 will also affect the number of oxygen atoms. So that means, what are we going to have for hydrogen after adding these 2 by show of hands?
We have Zora.
We'll have 4.
Thank you. So these 2, after adding it here, it has also made hydrogen 4. Which means that hydrogen is no longer balanced because now the atoms are not equal. So what can we do? Because Amelia discussed everything for us. What can we do to make sure that atoms of hydrogen on the right hand side also now equal to the atoms of hydrogen on the left hand side? Someone can tell us.
Shona.
We put 2 on the first hydrogen. First multiply 2 and then to
We
get
multiply
4.
by 2.
So
But these 2 that we've multiplied through, Shona is telling us, so yes, that we put it in front of hydrogen, on the left hand side of hydrogen. So I'll come and put a 2. Since hydrogen is alone, these 2 will only affect hydrogen. Thank you. So that is example 1. I'm going to example 2, but before that, I need to receive like 3 questions or 2 questions. Then we go to example 2, I receive more questions because the more we do more, after doing many numbers, you understand more. So for now, I'll be picking like 3 questions only. Then questions. Yes, teacher Martha. Michelle, are you the one speaking?
Yes. I was asking, so when they ask us to balance equations, we have to write all that working that you've written down.
Thank you very much, Michelle. Now, I believe that by the time we finish this topic, you'll be better than me in this topic. So when you're in an exam, we don't need to see all these things. They will, you can even use a pencil from the back of your paper. Then you just transfer 2 and 2. Then after practicing a lot, you do these things from the head. Find it easily comes, and you don't need to write anything. So in exams, we don't mark the working. We just need that 2. We also need that 2 only. The working is to help us learn what we are doing. With time, you may use your head. Next question. Michelle, I think that answers my question.
Yeah, you answered. Thank you.
Let's hear from Treasure.
So, teacher, the small tools before the hydrogen and the oxygen, they represent the number of atoms and not the valences.
Yes. This perfect. You understood very well. This original 2 represents that in real life, hydrogen gas is diatomic. They are 2 together before they react. In real life, oxygen, in real life, before they react, they are diatomic. That's what our teacher was teaching us last in our previous lesson. Then when they start reacting, that's when they start using their valence to form water.
Okay, thank you, teacher.
I think let me pick the last question, then more questions will come after example 2.
Let's hear from Charity.
I have 2 questions. First of all,
Yes, go ahead.
aren't we supposed to write 2H2O2 for when we are writing in this equation? Because
A minute, repeat. Repeat the formula that you talked about.
the formula of water is H2O, but so are these tools that we are putting, are they significant?
Oh, thank you. Let me answer your question, then other questions will come after. I said that if you remember what our teacher taught us, in real life, hydrogen there are 2. In real life, oxygen there are 2. If you look at your siblings at home, you're 2 or more. But when you come to school, everyone will do their exams separately. If let's say Arjuna, I'm doing geography, and I have a sister called, let's say, Jane. I'll do my papers, she'll do her papers. But at home, we are like under one roof. So it's the same thing here. This house of oxygen, there are 2 atoms. That's why we say it's diatomic. In this house of hydrogen, there are 2 atoms. That's why we say hydrogen is diatomic. But when it comes to reacting, each atom reacts on its own. Of course, they form the same thing. That's why we expect when they are reacting, now one hydrogen, because they are all reacting at the same time, but we represent it using 1. Has its valency, 1. Even here, many oxygen atoms are reacting at the same time, but differently at the same time. So I pick oxygen, has a valence of 2. This comes here, this comes here. That's how we are forming water. So these tools are significant to show us that these elements in real life, they are diatomic. But when it comes to reacting, the twos we don't consider them because now each atom is reacting on its own. Have I answered your question, my dear friend?
Yes.
Okay, I'm going to do example 2. After example 2, I will ask for more questions, okay? Have you finished writing this? Because I'm going to clean my board. Where is our document? It is here. Example 2, I see sodium plus oxygen forming sodium peroxide. Example 2, I have sodium, which is a solid, plus oxygen forming sodium peroxide. I'm going to remove the document, then we only see the board. Okay, let's watch. Can you all see the chalkboard very well?
Yes.
Yes.
Pay attention, then we ask questions after. Like here, this shows that sodium in real life, it's one atom, no more. But oxygen in real life, it's diatomic. What our teacher was teaching us, that's why we put a 2. Okay? Then our product is sodium peroxide. Sodium has a valence of 1. That is from the first lesson. Oxygen is not what we are using now. We are using a peroxide. Peroxide, remember peroxide has a value. That's how 2 comes here and 1 comes here. That's how we form sodium peroxide. So this is for revision purposes. You will do that as we are revising. That was our first section. But for now, I need us to focus on balancing. How many atoms of oxygen we have on the right-hand side? Just raise up your hand and mute yourself and answer. Sodium. I see so many hands.
Let's
Amelia.
1 atom.
Okay, let's go to oxygen.
Laura. Lorraine,
Left hand
sorry.
side.
Lorraine.
2.
Thank you. 2. Let's go on the right hand side, the ones that we call products. How many atoms of sodium do we have for products?
Denise.
2.
Thank you. Then for oxygen?
Destiny.
1.
2.
1.
I had 2
Type
answers at the
1.
same time. I need 1. I need 1 answer.
1.
Sodium is 2, oxygen is also
2.
2. Thank you. So, my job is to help us balance this. Thank you. If I look at sodium atoms here, on the left-hand side, we have 1, on the right-hand side, we have 2. What does that mean? It means that sodium atoms are not balanced because they are not equal when you compare the 2 sides. I go to oxygen. On the left-hand side, I have 2 oxygen atoms. On the right-hand side, I have 2 oxygen atoms. That means my oxygen atoms are very perfect, or they are fine. Electricity is off. I hope you can see my screen.
But you can see.
Can you still see
Quite
my
blurry.
screen?
Yes, it's quite blurry.
Okay. If it gets worse, I will use a whiteboard, okay? If it gets worse, you tell me so that I can use something else because electricity is off. Okay, let's continue and finish this number. The next number, I use a whiteboard. Okay, However much it's shaking, I can see. Can we finish this? Then we use the whiteboard in the next number.
Yes, teacher.
Okay. Now, on this part, you realize that we had sodium 2, but on the left-hand side it was 1. What do we do? By show of hands, what can we do to make sure that even sodium is fine?
Joanne, Amelia,
We put 2 sodium on the reactor to get, and then we put, so that way it is equal to the products. The 2 atoms in the reactor, sodium in the.
Okay, thank you. But your network was breaking, but I heard what you say. So thank you very much. She told us that we multiplied it by a 2, and then we put a 2 like in front of sodium, which means at this point I will have 2 sodium atoms and 2 oxygen atoms. So I will say that now my equation is balanced, or my equation is fine. Okay, I'm going to use a whiteboard in the next example, but in case there are any questions on this number, you can raise up your hands and ask. Yes.
Daphne, can you ask?
My question is that when you're balancing sodium, you put the 2 at the beginning. Can't you like put it after the symbol for sodium, like Na2? Or the 2 putting it at the beginning, it shows that you have balanced it.
Thank you very much. We say that when you're balancing, you cannot put a number on the right-hand side of a formula. Like here, if you put a 2 here, this is wrong because you've changed the whole formula. But we only put a 2 in front of sodium or on the left-hand side of sodium. So this shows that we have balance. You can see.
Rebecca?
Shall we be penalized in case we do not put the states of matter on the elements? For example, if I forget to put that sodium is a solid, will I be penalized even if my equation is correct?
Thank you very much. Are you seeing both my whiteboard and the chalkboard?
Yes.
Yes.
Thank you very much. Let me write so fast to use it to answer your question. Now, when we are marking, you see how we mark. A minute. Sodium peroxide. This is a solid. Okay, now how we mark is like this. When we look at an equation and it is perfect, correct, reactants are okay and products are okay, we give you half a mark. That is, I see sodium is fine, oxygen is fine, written well, sodium peroxide is fine. You watch. If you have state symbols, solid, which is okay, gas, which is okay, solid, which is okay, we give you another half mark. In case you forgot to put state symbols, solid, gas, and solid, you cannot get this half a mark. Then I check, is this equation balanced or it's not balanced? If the answer is yes, it's balanced, you put a 2 here. I come and give you another half a mark. That's why all equations in chemistry, they take 1.5 marks. Balancing takes half a mark, state symbols take half a mark, and a good correct equation also takes half a mark. I think I've answered your question.
Okay, Lindsay, do you have a question? Lindsay, I see your hand up. Do you have a question?
Yes, teacher, I'm asking about all the working. When you're done like that, is there a way to conclude or you just leave it like that?
Okay, thank you. As I've said, we said with time when you get used. We don't need to see this working. Because with time, after this topic actually, you'll be in position to write an equation. When you can do this, you can use this procedure as side work. Maybe you can write it at the back of your paper. But when we are marking equations, we don't need to see this working. We only need to see a balanced equation.
Johanna, any question?
Yes, teacher, I was asking, are we advised to use fractions just in case we want to balance the equations?
Oh, Joanna, thank you. Yes, you can use fractions. Perfect. If you understand how to use them, you can use them because they are even advisable to be used. After understanding this whole process, we'll decide to either teach you how to use fractions or we can leave because all of them are okay. But if you know how to use fractions, it is also fine.
Okay, Mr.
Okay.
Knight, those are the questions. You can continue.
We are going to do our last example for today. Then after the last example, you can ask more questions, then we can conclude our lesson from there. Let me share our... Okay, our third example. Can someone read it for us? Third example. Yes, Esther.
H plus, so hydrogen plus chlorine is equal to hydrochloric acid.
Okay, thank you very much. Hydrogen plus chlorine equals to hydrogen chloride gas, or what she said, hydrochloric acid. So let's start. Again, our job is to understand hydrogen. We need to state symbol gas. What does this mean? This means that hydrogen in real life is a diatomic gas plus chlorine. It also has a 2, meaning that it is also diatomic. But you said when they are reacting, atoms react independently. That's why we have hydrogen chloride gas. We can say hydrogen chloride gas. So first question, how many atoms of hydrogen do we have on the left-hand side? By show of hands.
Joanne?
2.
How many atoms of chlorine do we have on the left-hand side?
Daphne?
2.
Good. Let's go on the right-hand side. How many atoms of hydrogen do we have on the right-hand side?
Amania?
1.
Okay, next. How many atoms of chlorine do we have on the right-hand side?
Another person. Daphne?
1.
Good. So our main job here is to make sure that atoms on the left-hand side are equal to the atoms on the right-hand side, products and reactants. But you see that for hydrogen, these are 2, hydrogen, there are 2. On the left-hand side, on the right-hand side, it's 1. Chlorine, there are 2 on the left-hand side, then on the right-hand side, it is 1. So what can we do to hydrogen? Can someone tell us what we can do, or what we should do?
Johanna?
We should put 2 on the left-hand side of hydrogen chloride.
Okay, on the left-hand side of hydrogen chloride, thank you. So that means we are multiplying through hydrogen by a 2, which will give us 2. That means hydrogen is fine, but we can't fix 2 anywhere. It must be put in front of the formula on the left-hand side of this formula. So I come and put a 2. Now, something small that I need us to observe. We say that when we put a number in front of a formula on the left-hand side, it affects all atoms in this formula, meaning that hydrogen will be affected, also chlorine will be affected. Is that okay?
Yes, teacher.
So here I also multiply through by 2 because that 2 has also affected the number of atoms for chlorine, which will give me, how many atoms are we going to have for chlorine?
2.
So is this atom now balanced? Sorry, this equation now balanced?
Yes.
Yes.
Okay, thank you. Okay, I see we have 5 minutes. So I will need one of you to raise up the hand and do one number for me. The last number I want to do it with someone. So do you have a question 1 or 2? Then we can do that last number together. Those with questions, you can raise up your hands and ask.
Imelda Nakaita. Oh, Nakaita, do you have a question? Amelia?
No, teacher.
See your hand up. Amelia, do you have one?
Yes.
You go ahead.
I was correct the number of even if you don't, like here on hydrogen put, so is it okay if we don't put?
I've not heard your question very well. Can you repeat?
In the last number we did, the number of hydrogen and oxygen, we have got put 2 outside the bracket H2 and 2, but here we have not put correct.
Oh, thank you very much. I hope I've understood your question. I put brackets like this. Are these the brackets that you're talking about?
Yes, teacher.
Oh, yes. I only put these brackets to show you that these two affect all atoms in this formula. But we don't add brackets when we are balancing equations. I was just using them to illustrate how it affects the atoms in the formula. But we don't put brackets in our final answer. We just leave it like that. Since now we know that when you add a 2, it affects all atoms in the formula.
Charity?
Okay, so this one which we've written after balancing the equation, we won't be using it when we are actually writing the formula.
Thank you. Hope I've understood your question. When they just tell you write a formula of hydrogen chloride, we are just using radicals, okay? Formula, when they just say formula, you get your hydrogen with a valence of 1, a chloride with a valence of 1, you interchange valences. Remember, we don't write ones. Then the formula of hydrogen chloride is HCl only. We'll finish writing the formula. This is perfect. But then they say write an equation where hydrogen is reacting with chlorine to form hydrogen chloride. We add these two to make sure that the atoms on the left hand side are equal to the atoms on the right hand side. So when it is just a formula, we don't put these two like this. This is the formula, this is the whole equation. Have I answered your question?
Yes.
Okay, next question. I see we won't have time to do a number together. Any other question?
I don't seem to see anyone.
Okay, so students, we have 2 minutes. Let me see if I can utilize them very well. Then we can say bye-bye to each other.
Wait. Let me alone.
in chemistry, chemistry is a very nice subject because it can even train artists. I hear someone in the background singing. Okay, so because I see we have 1 minute, we may not do much. Let us try to practice those numbers off this screen. They're on our website. They're on their website. Is it Google Classroom? They are there. We sent them after.
Teacher, you resent the old notes.
We sent the old notes again.
The old notes, some part that wasn't sent. About 2 pages.
2 pages.
Yes.
Okay.
So the other one again, when I checked, it had some extra pages.
Okay. Now, these notes are still under, I would say, under manufacture. We are working on them. So we keep sending you what we are going to teach. We keep adding in a few pages, a few pages, a few pages. But these notes are already on the Google Classroom with these equations.
Okay, teacher.
Okay, bye-bye. Enjoy your lunch. See you next week.